Okay, so far we have studied the kinematics of particle, and in this under this topic we have covered the rectilinear and curvilinear motion, and we looked at that if the body or particle move in a straight line, then how we can calculate its position, velocity and acceleration. Similarly, we studied that if the body or particle move in a curved path, then if we want to analyze its motion and we want to see that what will be its velocity, position and acceleration with respect to time, then its motion can be defined with different coordinate axes like rectangular coordinate axis, normal and tangential coordinate axis and cylindrical coordinate axis. In both of the cases where uh, it would be a rectilinear motion or a curvilinear motion, we will study that the particle will move independently from one point to another, right? But there can be exist a motion in which our particle is dependent on some other particle, or the motion of our particle depends on the motion of the other particle. So now we are going to study that our if our particle is connected with some other body and both motion is interdependent, so how we can analyze the velocity, acceleration and position of such cases. So we are going to start the absolute dependent motion analysis and see that how we can uh, study their motion when they are interconnected with each other. So let's move ahead and see the further details of the topic. Okay, before dissecting this dependent motion analysis, first of all, let's see this scenario. uh, which we have a pulley arrangement, and we can apply the force over here from at point A, by which this mass B will move in upward direction, right? So by using some statics uh, principles which you have learned in your uh, first year, can you tell me that how much uh, weight can I lift by using the force? For suppose if uh, I'm applying some force which is Fa over here at 50 pounds, right? If I'm applying the 50-pound force over here, uh, what is the amount of the weight which I can lift in upward direction? How will you calculate it? You will simply draw the free body diagram, and over here you have a pulley, right? And you have two forces. This is the free body diagram of this. You have a weight over here at point B. So this is the tension which is just transferring from that point to this point. So you have a T over here and you have a T over here, right? So what is the value of the T? This is the 50-pound force actually. So this is 50 pounds. This is also 50 pounds, right? So by applying the equation, which is sum of F is equals to 0, you can calculate the weight. So this will be 2T minus W is equals to 0, and you will get the weight of B by 250 into 100. So did you observe that by applying a 50-pound force you can lift double the weight, right? So by applying 50-pound force you can lift 100-pound weight at this point. So that is the mechanical advantage of this pulley, that you can lift double weight by applying the force over here, right? So now I am interested in finding out that if I apply the if I am applying this force over here and this point move with a velocity of 2 feet per second, at what velocity will this weight lift, right? uh, Now the problem is that if I am applying the force 50 pound with a velocity and this point moving downward with a velocity of 2 feet per second, so what is the velocity by which this weight uh, uh, moving in upward direction? So so this is the problem which now we are going to solve. So this is actually the dependent motion analysis, in which the motion of one body is dependent on the motion of the other body, right? In order to solve such problem, we are now going to see the procedure that, and you know that velocity is a kinematic parameter, and we are going to see that if our motion of the two bodies are interdependent, then how we can calculate uh, this its velocity and acceleration. So let's move ahead and see the detail of the topic. Okay, my question was that if we are, for suppose this is point A, right, and it is moving with velocity VA by 2 feet per second. So with what velocity this mass B will move in the upward direction, right? So in order to solve such problem, we have a procedure that, number one, you have to identify the uh, uh, a stationary point and you will mark it as datum, and from that point you will calculate the position of the other body. So this is our datum or a reference point. So define datum. Number two, mark the position of the object which is moving from that datum. So over here you can see that this is the point A. When we move it in downward direction, it will move down and it will move up. So this is the point B, and this is the point A, which is moving upward and downward direction, right? So it will cover the distance in the downward direction, it will cover the distance in the upward direction. So that is why we are seeing that these points are moving away and towards the datum. So initially, if it is at the position at this point, so we are marking with it with SA, right, and we are marking it with SB, right? So this is that is how we have defined the position of the objects which are moving away and towards the datum. Now we have to calculate the total length of the, so define datum, define position, right? Number three, write the equation for the total length of the segment of the cable. So what is the total length of this cable? So this is the total length. Here is our cable. It is This is the total length, right? So you can see that while these points A and B moving upward and downward, the distance will be when it is towards the datum, this distance reduces, and this and body B move away from the datum. So that is why these distances are changing. Whereas this is the segment of the cable uh, which is wrapped on this pulley, and this is also the segment which is wrapped on this pulley, and the motion is not affecting this length of the pulley, right? So in order to calculate the total length, for suppose we are saying that this is the total length of our cable. Number one, this is SA, plus this is the constant segment which is wrapped again on this pulley, so we are calling it C1. So SA plus C1, similarly plus SB, then this is C2, right? Plus C2, plus this is the same distance as B, right? So this is the whole length of our cable. So you can write it in this form. Now we have to first differentiate it with respect to time. So first time derivative. So when you differentiate it, the total length of this cable will not change. That is why when you differentiate it, it will become 0. This become dsa by dt, right? This is also constant. It will also become 0, and this will become 2sb. So plus 2sb dt, right? So this is the first time derivative. And you know that the rate of change of the distance will be the velocity, right? So it will become va plus 2vb is equals to 0, right? And you know that you have a va which is 2, and so your vb become 1 minus 1 feet per second, right? So you can see that as this is moving with the velocity 2 feet per second downward, this body B is moving with the velocity of 1 feet per second. So half of the velocity by which this point is moving in the downward direction. So it is much slower. So you can compare that when we have some advantages, on the other side we have disadvantage. We can lift the double weight but the velocity reduces by half as well. Negative sign is showing that this body is moving in the upward direction, right? So that is how we can calculate the velocity of the bodies which are connected to each other. Similarly, we can also calculate the acceleration by the second time derivative, and when you uh, this is the second time derivative. So when you calculate it, you will get the acceleration, right? So this will become a plus 2ab is equals to 0, because derivative of the velocity you will get the acceleration. So that is the procedure for calculating the velocity acceleration of the position of the bodies whose motions are dependent on each other. So now let's move ahead and solve the problem related to the dependent motion analysis. So please read the respective topic in your RC Hibdar book. and solve this reading uh, quiz, and we will discuss this in our live class, right? So let's move ahead and solve uh, numerical related to absolute dependent motion analysis. So this is the problem of your RC Hibner, which is 12-195, and you can see that in this problem you have a cord, and the uh, bodies are connected to it. So you are applying the force over here and you are pulling it in the downward direction. As a result, this body will move in the upward direction. Over here you can see that there are two cords, right? One is this and the other one is this. So the velocity by which point A is pulling downward is 2 meter per second, and the block is moving in upward direction, which we will have to calculate. So we have to find the speed of the block when the speed of the force or at point A is 2 meter per second. So I have told you, in order to solve this problem, first of all you have to define your datum or the reference point from which you are calculating the distance of the moving bodies. So this is an important point. So you we are marking this as our datum, right? This is the stationary point, and after that we will mark the position of the different moving objects. So please visualize that when you move the point A in the downward direction, as a result this whole segment will move upward, which result in the movement of this pulley in upward direction, right? So independently this uh, pulley is moving upward and downward, this pulley is moving upward and downward, and this point A is moving. So we are marking their position, right? So this is the constant length, that is why we are not including it in our study. So this is, for suppose this is point B, so this is our SB, this is our SC, right? And this is, for suppose this is our SA. Okay, so we have marked the position of the moving bodies, and after that we have to write the equation for the total length of the chord. So here we are two chords, so we will form the two equation. So number one is we have this for suppose this is L1, and over here you can see that this L1 will be uh, SB SB plus SB minus SC, right? So this is the length, this is the length SC, so this is the whole length minus plus this SB. So this is the length of the chord L1. Now we can also write the length of the chord 2, which is this SA, and this is 2SA, right? So this is 2SC 2SC plus SA. So you have formed the equation. This is equation 1 and this is equation 2, right? Okay, then we will take the first time derivative. So this equation 1 will become 0 is equals to uh, 2VA 2VB 2VB minus VC, right? And this equation 2 become 0 is equals to 2 VC plus VA, right? So you have this equation and you have to calculate the speed of the block B. So over here you can solve it. So this VC will become 2VB, right? And when you put the value in equation 2, it will become the 0 is equals to 2 VC is 2VB plus VA, right? So on solving you will get 4VB plus VA, or you have to calculate this speed which is P. So this will become VB minus VA divided by 4, right? So this VA is 2, so our VB will become minus 0.2 meters per second. So the negative sign indicating that one body is moving downward and the other body is moving upward. So this is the way which you can solve uh, for the kinematic parameter of the bodies which are dependent to each other. So let's move ahead and solve another problem. So this is the problem 12-205 of your RC Hibbeler, in which you can see that these three bodies are connected with each other and their motion depend on each other. And it is said that the block A is moving downward with a velocity of 6 feet per second, and this block C is moving downward with the 18 feet per second, right? And we have to calculate the speed of the block B, right? So from the uh, figure you can say that this is a dependent motion, and in order to solve such problem, first we have to define the datum. So datum is a fixed line from which you observe the motion of the bodies, and finally and then after that you will mark the position of the different bodies separately. So this is C, so this is SC, this is SB, and this is SA, right? And after that you will write the equation for the total length of the cable. So over here total length of the cable will be 2SC plus 2SB plus SA. So this is the total length of this cable. So when you differentiate it with respect to time, then you will get the 0, 2VC plus 2VB plus VA, right? So your velocity of B is required, that is why I put the values in equation. So 2VC is our 18 plus 2VB is our required velocity plus VA, which is 6. So when you solve it you will get VB is equals to minus 21 feet per second, and over here minus sign indicates the block B is moving in the upward direction. So this is your answer, and you can adopt similar procedure to solve the problem related to dependent motion analysis. I would suggest you to please read this topic in the book and solve this attention quiz. So let's solve another problem. We have a tractor at A and we have another body at B, and when this tractor move in the forward direction, this body move in the upward direction, right? So this is our pulley arrangement and the cable, and we have to determine an expression for the upward velocity of B in terms of the x, right? So we can see that when this tractor moves in the upward direction, this body B move in the upward direction. So this its motion is dependent on this body. So this is a dependent motion analysis problem, and in order to solve such problem, we have a number of steps. Number one, we have to determine the datum. So over here, this is our datum, right? And over here, this is our datum. And after defining the datum, we define the position of the objects. So here is our A. So we are marking uh, we are this is the position x from the datum, and here is the position uh, h and y from this datum, the distance of the objects from the datum which is moving apart and their motion is dependent to each other. So after that we will find the total we find the total length of the cable. So over here the total length of the cable will be this length L plus this 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 length, which is actually h minus y. So it will 2h, it will 2h minus y, right? So this is our equation. So what is this length? We can find this length by using the right angle triangle ratios, which is by using Pythagoras equation, and it is h square plus x square power half, right, plus 2h minus y, right, and this will become 0. And when you solve it, or when you differentiate it with respect to time, then you will get so when you differentiate it, then you will get when you differentiate it with respect to time, then it is half uh, h square plus x square into minus half, right? Then you will differentiate this term, and you will get 2x into x dot, right, plus sorry, minus 2 dy by dt. So this 2 and this 2 will be cancelled, and you are left with x into x dot divided by h square plus x square minus 2 y dot, right? And you can say that this x dot is dv, is the velocity of a with respect to time. So you can represent this x dot as VA, right? And this y dot is the velocity of the bale B, so this is VB. So you can, in order to make the expression for the VA and VB, you can replace it and can write it as VB is equals to half of XVA divided by h square plus x square, right? So this is your answer. So you must have observed that we have adopted the similar procedure by which we have solved the problems in the previous slides. So this is the procedure by which we can uh, analyze the dependent motion analysis and can find out the position, velocity, and acceleration of uh, the particles, right? So the topic ends here.